Just understand this one point, that when we are talking about reflection, suppose this is a surface. Now this is surface, some kind of any kind of surface. Suppose let's say it's your book, or maybe it's a mirror, or maybe it's something else. We don't care, but it is just a surface. And there is one incoming light. Incoming light. Okay, this is suppose light ray which is incoming, which we call incident ray. Incident ray means what? Incoming ray. Incoming light ray. Suppose this is the incident ray. And what is going to happen is, suppose it has come from air, and what is going to happen after it strikes this particular surface? This light is striking that surface, then what is going to happen?
Reflection.
Okay, it is going to bounce back. Correct? It is going to bounce back. The word we are going to use is bounce back. And this is exactly what we call reflection. The light came from air, and again it is traveling to air only. Now, suppose let's say, give me any liquid or gas, any example if you have. Chalo, any example of liquid.
Water.
Water, anything else? Acha, forget about water. Okay, water is okay. Gas example.
Oxygen.
Okay, oxygen will do. Okay. Now consider that the light is traveling through water, and if you are talking about suppose reflection, so in case of water, the light should come from water itself and it should reflect also in water only. This particular substance through which light is traveling is called as medium. So what exactly is the medium? The substance through which light is traveling. So what can be the medium? It can be solid, it can be liquid, it can be gaseous. Doesn't matter. Light can travel through anything. So solid, liquid, or gas. That is another question. Suppose let us say we have a solid object, like suppose for our book, the light is not going to travel through it. That's okay. That is another part. That is something which we study under opaque, translucent, transparent materials. But right now, what we are going to say is medium is what? A substance through which light travels. Now, water is one of the mediums. Oxygen is one of the mediums. Air is also one of the mediums. Now, main condition is that for reflection, the light should bounce in the same medium. The light should bounce in the same medium. What does this mean? Suppose the light is coming from air, after reflection, it should go again in air only. Suppose the light is coming from water, the light should again, after reflection, should go in water only. What if the light is coming from petrol? It should go in where, according to reflection?
Petrol.
Petrol.
Petrol itself. That means the medium should not change. The medium should be same. That's the very basic condition. So can you please underline this particular line in your book? This is the definition of reflection. This one. Reflection is the phenomenon of bouncing back of the light in the same medium. Now let us have an example. Suppose this is our surface, and this is our incoming ray, incident ray. Can I say, suppose the light might travel back in the same medium? That is the first way. Second thing, it might travel through the surface. Matlab, like, through and through. The light has traveled through the surface. And the third thing is that it might be absorbed. What is this first one? What we are calling this? Reflection, right? The light might be reflected. That is the first point. Second point, the light might also be absorbed by the substance itself. And the third thing, it is passing through the surface. This third thing is called as refraction. Refraction. Okay. So let us just revise this. How many possibilities are there if a light is incident on a surface? How many possibilities are there?
Three.
Three, right? Okay.
Three.
Uh, one is first is
Reflection.
Reflection.
okay. Reflection. What is the basic property of reflection? What
It
about
bounces
medium?
back in same medium.
Main property is about the medium itself. Medium doesn't change. Same medium. Second possibility with the light.
Absorption.
Absorbed by
Right.
the substance.
Absorption.
Okay, so absorbed by the light, absorbed by the substance itself. Third thing, uh,
Refraction.
ref-
Partial.
Refraction.
refraction. But let us understand this. For example, if this is air, this is another certain kind of substance. Suppose, let us say it is water. Can we say for refraction, it is completely opposite to reflection? In reflection, the medium should say, let's say it should be same. But in refraction, it should be different. Okay, so the basic condition for refraction is that medium changes. Medium changes. Okay, so let us have an example over this. Suppose the light is traveling from petrol to diamond. Is the substance different?
Yes.
Yeah,
Yes.
obviously, petrol is different, diamond is different. Then is it reflection or refraction?
Refraction.
Refraction.
Obviously, refraction because the medium has changed. Obviously. And what if the light is traveling from petrol to petrol?
Reflection.
Reflection.
Okay, good. Reflection. What if the light is traveling from petrol to diamond to petrol again? See, in such cases, what you have to do is you have to think about it in individual terms. Like, for example, you need to compare these two first, and then you need to compare other two, the remaining two. Okay, so what about petrol and diamond? Is it reflection or refraction?
Refraction.
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 This is definitely refraction, medium is different. What about diamond and petrol? Second case.
Refraction.
Refraction.
Okay, again refraction because the medium is not same. We can understand that, see, petrol and petrol is same, but the light is not traveling from petrol to petrol directly. That light is traveling from petrol to diamond to petrol. That doesn't count as reflection. It is refraction only. Okay. Now, main question, just for you. So there are three possibilities. Agreed? One, two, and three. Reflection, absorption, refraction. What do you think out of these? What is happening with the surface? Suppose let's say light is incident. Out of these three, what might be taking place?
Reflection.
I think you are not understanding the concept. I said possibilities, right? Possibilities. What do you mean by possibility? Is this the meaning like we are saying that it's a guaranteed thing, it's going to happen? What do you mean by possibility?
It
It might,
has a chance of happening.
Chance of.
chance of happening, correct. It is not, there is no guarantee. It might happen. So you have to understand that three possibilities, all the three are going to happen at the same time with a surface. Suppose let's say the light is traveling from air to water, all these three things are going to happen. Reflection is going to happen, absorption is going to happen, refraction is also going to happen. All these three takes place at the same time. But are we going to study them like simultaneously? No. We are going to study them individually. We are going to study them individually. And out of these three, which will be the main point or focus of this particular lesson? It would be reflection. Absorption we don't have it because the light is absorbed. There is nothing to, let's say, teach from absorption. And refraction we just have a small paragraph at the end. Okay. So out of these three, are we? First question: do they take place simultaneously? All these three: reflection, absorption, refraction. So just simple question. All these three things: reflection, absorption, refraction. Do they take place simultaneously?
Yes.
No.
Yes, they do take simultaneously. But are we going to study them like in a combined way or individually?
Individually.
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 Individually. And our lesson is based on what out of these three?
Reflection.
Reflection.
Reflection. And refraction, we just have a small paragraph. Okay, so main part is just, you can see uh, this whole section is about reflection only. There is a very little part of refraction, just a one paragraph, and later part is just about our human eye. Okay, so the major part is about reflection. So let us see what are the laws, what are the things. Chalo, but before we get into that, I want some examples of medium. Chalo, I want some best good examples of medium. Chalo, solid example. Any medium?
Mirror.
Okay, DK, mirror can be the one. Anything else? You can use any substance. That is not a problem. There are different examples of solid, right?
Glass.
Glass, of course. Can't you
Table.
table? Can't you see around yourself? See, you are sitting in a room, right? There are all solid objects. There is bed, there is a table, there is yes, there is laptop, there is pen, there is tablet, there is pencil, there is rubber. Come on, there are so many things. Give me example for liquid.
Yes,
Huh?
Water.
Water,
lemonade.
Petrol.
lemonade,
Juice.
petrol. Okay, petrol, diesel. Okay, everything. Juice also. Okay, ठीक है, चलो. So you have lots of examples of what I can say mediums. Gases, huh?
Carbon
Like
dioxide.
carbon dioxide, oxygen.
Oxygen.
Dust.
Okay, so dust particles will come under solid, not gas. Dust particles will come under solids. Okay, so we have CO2, we have N2, we have O2, oxygen, nitrogen, carbon dioxide. We have so many things. So all these are medium. The light, let's say the substance through which the light travels is called as medium. Chalo, we have seen a lot of things. Let us talk about reflection of light. Okay, reflection. So this is your surface and this is your incoming ray. This is incoming ray. And what is the technical name for it? It is called as incident ray. Which ray? Incident ray. The point where it hits the surface is called as point of incidence. Point of incidence. What is this point? This is the point where the light strikes. Point of incidence. Now this is outgoing ray. Outgoing ray is called as, in technical words, what do we call it?
Reflected ray.
Yes, obviously it is reflected ray. Okay. Now, can somebody give me the concept of perpendicular? What is perpendicular represented by like this in mathematics?
90 degree.
Yes, perpendicular means 90 degree, correct? Okay, so and 90 degrees shown like this, correct? Okay, so that means if I have a surface like this, if I want to have a 90-degree angle over it, I just have to draw a perpendicular line and this is your 90 degree, correct? Now, I want to measure some angles. So what I will do is, do you have that concept as, let's say something called as, let us just have some examples over it. I just want to ask you something over this. When you are suppose let's say concepts of geography like latitudes and longitudes, are they real? Do they exist on Earth? Longitudes and
No,
latitudes.
they are imaginary.
No, they are imaginary. They are imaginary.
Oh, obviously imaginary, and we study them just for location purposes, right? There are various uses of latitudes and longitudes, and those are imaginary lines. In the same way, in this whole experiment, we have one imaginary line, and we call it normal. This dotted line, why we are showing it dotted? Because this is imaginary, and what we call it? We call it normal. And what is this normal? This is perpendicular to the surface. Normal is basically a perpendicular line to the surface. That's it. Okay. So don't take the actual word meaning. Like we say, like how are you? So we say that we are he is normal or they are normal. Not the English meaning of normal. Normal in physics means what? Perpendicular drawn to the surface. Nothing to do with the English word. Normal, which you know as English word, that is completely different. What is normal for us? Perpendicular. Always remember this. And why do we draw it? Is it real or imaginary?
Imaginary.
Obviously imaginary. And why then we draw it? To find out angles. Okay. We draw it to find out angles because we want to know what kind of angles there are. So now incident ray and the normal, there is an angle between them. And that is going to be called as angle of Incidence. This one. Angle of incidence is between incident ray and normal. And what about the reflected ray? What we are going to call it?
Angle of
Angle
reflection.
of,
Angle of reflection.
okay,
Reflection.
obviously we are going to call it angle of reflection. And this we are going to call it angle of incidence. Very simple. Okay, so we have angle of incidence, we have angle of reflection, and we are representing this with letter I and letter R. Question is it compulsory to represent them by angle I and angle R? Yes, those are notations. So in the exam, they will ask you what is angle I. So this is the angle between what? Incident ray and what?
Normal.
Normal.
Normal, because normal is the one which we use to measure angle. What about R? Angle
Between
between what?
normal and reflected ray.
Reflected ray and normal.
Normal and reflected ray.
Yes, reflected ray and normal. So that is okay if you are saying it normal and reflected ray or reflected ray and normal. Doesn't matter if you are changing the sequence. The answer should be same. Now, there are some laws based on this. Some laws. Now, what is this angle I and angle R? These are angles, right? The first law says that these are equal. Angle I and angle R will be equal. Now, for example, suppose this is 55 degree, which is angle I, then how much will this be? Angle, suppose let's say R.
Also
55 degree.
55 only. Matlab like it's same, one and the same thing. Acha, just asking you a question. Suppose this is 50. Suppose. What do you think this must be? If total is 90.
40 degree.
40 degree.
Obviously 40 degree. Very simple, right? So you can find out bottom angles also. Matlab like if you know the angle of incidence, it is very easy to find out the bottom angle. Acha, what about then this angle? How much is this?
50 degree.
50 degree.
Obviously 50. And then what will be the remaining one?
40.
40 degree.
Because total is 90, this is 50, then this must be 40. Okay. So can you please add both, let's say all of them, 40, 50, 50, 40. How much is that?
180.
180.
180.
Now that's correct because what we are trying to identify is the angle between a line, let's say a complete one. That is 180 degree. Correct. So the total angle is 180. Okay. So will you be able to find out some angles if I give you some questions on this? Right now. Interested? Sure.
Yes, sir.
Just have to tell me. Mm, 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 mm. Kindly let me know angle of reflection in this case.
70 degree.
70
70
degree.
degree.
70.
Yes, obviously this is 20 and this must be 70. This another must be 70 and this is 20 again. So if this is incident ray, then definitely this is 70 again because I and R are same. 70 degree. Okay. Kindly find this for me, please.
85. Sorry, 75.
75. 75.
Okay. Can you please read the statement? See, angle between what? Incident ray and reflected ray. What is incident ray?
150 degree.
This is
One.
incident ray and this is reflected ray. They are asking angle, this angle, like angle between incident ray and reflected ray. How much will this be? This is 75.
150.
150
This is
degree.
70. Co-
150.
Correct, correct, correct. So they are asking for 150 degree. I think this was interesting. Chalo, so that fun is over. Let us go for the next point. So what is our first law? Angle I and angle R are same. Angle of incidence and angle of reflection is same. That is the first law. First law of reflection. Now let us talk about second law. Incident ray, reflected ray, and what is the third line which we are drawing?
Normal.
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 Normal. Okay, all those three things, they lie in the same plane. They lie in the same plane. Now what do you mean by that? And this plane doesn't mean that plane, huh? Not aeroplane. Same plane means what? They lie on the same axis. Same axis. Suppose for example this is on x-axis, then others will also be on the x-axis. I hope you know there are two axes, x-axis, y-axis on the graph. So if one is on x-axis, others will also be on x-axis. If one is on y-axis, everything else will be on y-axis. So have you understood the meaning of this word? Same plane means what? They lie on the same axis or they lie on the same dimension. We also call it same dimension. Okay. Can you please underline this word in your book and write down there what is the meaning of this? Same axis or same dimension. So it will be very easy for you to later on correlate with the concepts. Let me know you once you are done, once you are written. Same axis, same dimension.
Done, sir.
Done? Okay, good. Okay. Now, let us see this particular experiment. The boy is, let's say, watching through a pipe, a particular candle flame. Now, he is able to see this in this particular first arrangement. The light traveled through this pipe to his eyes and he was able to see it. Visible, that flame was visible. But in this case, let's say the light ray is not visible. Can we say the light is not traveling, let's say, towards his eyes? Correct. So it's not visible. Question is why? Don't you think it's like it should flow like this? Something like this. What is the difference between the two?
So in first, light travels in straight line, and in second, light
See,
will not travel because the path is straight ahead.
yes, okay, a good try. See, the difference between the two is that in this case, the light is traveling in straight line. Straight line. And in this case, the light is again traveling the straight line only, but the problem is that due to its straight nature, the light is not traveling beyond this point. It is not bending. Okay, so that's the problem. So that's why you are not able to see it. So with this particular experiment, what we can say? That the light travels in straight lines. Always the light travels in straight lines. Always remember this, a very important concept. Can you please underline this? In the exam, they might ask you. Light travels in what kind of lines? Zigzag lines, curved lines. So all you have to remember is they travel in straight lines. One of the basic property. So have you seen, let's say, I hope everybody, let's say, must have taken bath today in the morning. Have you seen yourself in the mirror, your home mirrors, at least today or maybe yesterday? Home mirrors.
Yes.
Yes, agreed. Okay. So your home mirrors are called as plane mirrors. Your home mirrors are called as, we have a special name for it. We call it plane mirrors. So we just want to know what are the properties of it. So I will just ask you certain questions and you have to give me the answer, fine? So that it will be an interactive session. Tell me one thing. When you look yourself in the mirror, uh, let's say, if you are watching your face, is your face bigger in size in the mirror, of same size or smaller size?
Equal size.
Same size.
Same size. Same.
E- e- Same size, right? So that means whatever you see in that mirror is just you. So can we say Image means the thing which is created in the mirror. So image size is same. That's the first point. Agreed? Image size is same.
Yes, sir.
That's the first point. Another point. Second question. Now, I will just give you two pictures, and I just want to make you understand. So this is the mirror, and suppose this is you who is standing in front of it. Suppose the image looks like this. Suppose. Just assume for a second. And there is another mirror in which you stand in front of it, and let's say this is the image what is looking like. This is you, this is object, and this is the image. Object means you. Okay, what is the difference between the two images?
Sir, one image is upside down.
Yes, one image is upside down, right? This one. Okay, so that upside image down is called as inverted image. What we call it? Inverted image.
Inverted.
And this is not upside down. Okay, so this we are going to call it erect image. What kind of image? Erect image.
Erect.
Now, out of these two, let me know from your own experience. When you stand in front of the mirror, do you see your head upside down or you see the same kind of image?
Kind of.
Same kind of
So,
image.
so then what kind of image you are getting at home?
Erect image.
Erect image.
Image.
Okay, so that we are very confirmed it's erect image. Very, very, very confirmed. So that is the second point we have covered. Now, another question. You must have, suppose, let's say, tried this experiment at home. Suppose this is you, and this is your image. Suppose you move back 5 meters. Suppose you move back 5 meters. What do you think your image will move like?
It will move back and get slow.
Again with 5 meters only. Agreed? Like whatever, let's say the distance you have or you are changing, the same distance will be changed by your image also. Very simple.
Yes.
You must have checked inside your mirror, you must have moved backwards and forwards, and you must have seen how your image travels. So can we say the distance between object and mirror, the distance between object and mirror is same as distance between image and mirror? Can we say like this? Okay, so that's
Yes.
the third point, that
Yes.
object mirror distance is equal to image mirror distance. That is the, let's say, third point we are going to understand. Now, another question for you. When you look inside the mirror, suppose this is your right and this is your left. When you raise your right hand, does the image also raise its right hand or left hand?
Left hand. Left hand.
Okay, so you must have seen that if you raise your right hand, it looks like the image is raising its left hand. Okay, so that is called as lateral inversion. What do we have? The name of the term is lateral inversion.
Lateral inversion.
And what do you mean by this? That right becomes left and left becomes right. Right becomes left, left becomes right. So do we have this in our home, lateral inversion? In home mirrors?
Yes.
Obviously we have. Lateral inversion, definitely we have. Lateral inversion. Okay, so this is another point we have added. So let us see how many points we have covered. Size of the image, same as the object. Distance is equal. Upright. Okay, vertical in position. Upright. What we have used the word for upright?
Erect.
Erect. Okay, so kindly please just write down erect, because see, upright is just for 8th standard, but for higher grades 10th, 11th, 12th, you will require this word erect. So it's better to remember erect only. Upright is also correct. Okay, and lateral inversion. Okay. Now, see, you must have gone to theaters, right? And like cinema halls and movies and all. So can we say the movie is projected on a piece of cloth or maybe some kind of fabric, and on that particular thing we are watching the movie? Agreed? The movie is projected.
Yes, sir.
Okay.
Yes.
So there are two images.
Yes.
One image is called as real image. There are two types of images. One is called as real images, one is called as virtual image.
Virtual.
Now, out of these two, let's say the real images, they can be taken on a screen. And what do you mean by screen? Screen is nothing but suppose a piece of paper. For example, suppose there is some certain kind of surface over this, and suppose let's say this is incident light. This is incident light. And suppose we keep a piece of cloth here or maybe paper, what we are calling it screen. Screen is nothing but suppose a piece of paper, cloth, whatever you are using to take the image on. So this is suppose screen. And if the image can be taken on the screen, it is called as real image. If an image can be taken on the screen, that is going to be called as a real image. Now, just asking from your own experience, just imagine that your brother came and you are standing in front of the mirror, and what he did was he put some cloth in front of it. Not on the mirror, but just like in the sideways. uh, will you be able to get your image on that particular cloth like this? Is it possible?
No.
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 No, it's not possible, right? So can we say the rays are not traveling in that place? Obviously we can't get it. So if you are not able to get image on the screen, so what kind of image do we have then? Virtual or real?
Virtual image.
Virtual
Virtual.
image.
Virtual.
Okay, so we cannot take it on screen, not on screen. So definitely that is our last property, that whatever the images we are getting, they are virtual. Obviously virtual. Okay, so let us just revise this. Let us revise this because that is what is important. First question. Our image size in plane mirror, is it large, same, small?
Same.
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 Same. Uh,
Same.
is our image virtual or real?
Virtual.
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 Obviously virtual. Is our image erect or inverted?
Erect.
Erect.
Direct.
Erect. It's not upside down, it's erect. Fourth. What about the distance between the, let's say it's same, right? Okay, so that point we don't need to discuss. That phenomenon is called as, in which the left becomes right and right becomes left?
Lateral image.
Lateral
Lateral.
image.
Lateral
No,
image.
not just lateral image. It's called as lateral inversion. Okay. The name of the phenomenon is lateral inversion. Complete name. Please remember that. I know it's somewhat hard to pronounce, but you will get familiar with it. So the image is called as lateral inversion. That phenomenon. Okay. So, do you have any doubts regarding this? Please let me know.
माझ्या आजीचं आहे.
No, sir.
No, sir.
द्या मंदिरला.
Sir, I want to ask something.
Yes, please.
Sir, in the mirrors of the car, it is written that objects are closer than they appear. So what
Yes.
does it mean?
What do they mean is that they are using a special kind of mirror. Just 1 minute. Chaitanya, can you please turn off your microphone? It's creating disturbance. Okay. So the point is that, issue is that whenever you are talking about the mirrors in the, let's say, the cars as such, they are basically spherical mirrors. They are curved, and because of that, it might happen that they are, suppose let's say closer, but they might not appear. The reason is that because of the property, we will not be able to explain it completely because that is a topic in class 10th. So you just remember that that's not your regular mirror. It's a spherical mirror. It's not your home mirror.
Okay, sir.
Anything else? Some doubt from
Sir,
today?
and you told that you will send notes of sound chapter.
Yes, once it is created in the upcoming week, we'll be sending it. And we will also discuss once the school start, let's say our regular classes of science, and suppose that is also in the planning process. So we will talk about it, but once the school starts, right? Physically, it's going to start. And in that particular thing, we will discuss about this.
Okay, sir.
Okay. Chali then, thank you so much for today. And we'll meet in the next session in the school itself because it's going to be physical. So let us meet and learn something more.
Bye, sir. Have a great day.
Okay. You too,
Bye,
beta.
sir.
Enjoy.
Thank
Bye,
you,
sir.
sir.
Have a
Bye.
nice
Have a
day.
great day.
Yes, you too. Bye.